friends, welcome back. Today we're talking about graphing rational functions. Previous video, you learned how to find the vertical asymptotes of a function, and today we're going to talk about finding the horizontal asymptotes. Now, grab your notebook because this is a really hard part. I think this is the hardest part of graphing rational functions, is just remembering this stuff. So, grab your notebook. You're going to want to write this down. Now, it's kind of cheesy, but this is how I remember this. Bobo Botan, so like a robot, right? That's why my terrible drawing of a robot, eats DC. Bobo Botan eats DC. This is just a mnemonic device to help you remember how to find these horizontal asymptotes. And what this means is Bobo means bigger on bottom than y equals 0. Botan means bigger on top, none. There's no horizontal asymptote, but you're going to want to check for a slant or oblique asymptote. That'll come up in a different video, but I do want you to notate that now. Eats DC. Exponent, if the exponents are the same, you're going to divide your coefficients. Now, this probably doesn't mean anything to you at the moment, but it will in just a second. Write that information down. At the very least, you're going to want to write these three things so that you can reference that. Okay, so let's take a look at our first one. For example, if we have example number 1, negative 10 divided by x squared minus 9. Now, the very first thing that you want to do is factor. So we're going to do this. Y equals negative 10 over, and this is a difference of squares, x plus 3, x minus 3. Now, in a previous lesson, we learned about finding those vertical asymptotes, and to do that, you just set you set your denominator equal to 0. And if I do that, I get x equals negative 3 and x equals positive 3. Now let's talk about finding that horizontal asymptote. Again, Bobo Botan eats DC. Now, the horizontal asymptote is where you're going to compare your two exponents. This exponent in the denominator here is squared. This guy, and I'm just going to put this in here so you can see, if I add x to the 0 power, remember anything to the 0 power is 1, so negative 10 times 1 is still just negative 10, so I can leave that there and not have it affect anything. Now, what does this mean? Our exponent is bigger on the bottom, bigger on the bottom. Remember, if it's bigger on the bottom, y equals 0. Bigger on bottom, 0. So our horizontal asymptote in this case would be y equals 0. Now let's go ahead and take a quick peek at this. So if you take a look, if you go out to Desmos, you'll see this is the landing screen. Let me just show you that really quick. Desmos, so you just type in desmos.com and your landing screen is going to look like this. And you're going to hit graphing calculator and you end up with this screen. And if you do that, you're going to type in your information. Notice I have my negative here. It's in the front. Just be very careful that you do see that. So I have negative 10 over x squared minus 9. Now, in that case, this is what it looks like. And we're talking about our horizontal asymptotes. Remember, I said my horizontal asymptote is y equals 0. And sure enough, you can see all along here, you've got it's not going to cross at 0. The other thing we said were vertical asymptotes. Those occurred at 3 and negative 3. And you can see, sure enough, those vertical asymptotes are at negative 3 and 3. Okay, so let's take a look at the next one. We have this guy right here. X squared minus 10 and x squared minus 4. Now, I said you want to factor these. X squared minus 10 I can't factor, but the bottom is, again, a difference of squares. X plus 2. X minus 2. You factor this for two reasons. One, it helps makes it easier for you to find your denominator, your vertical asymptotes, because you have to set your denominator equal to 0. And two, because if you cancel something out, so let's say we had an x squared up here and an x squared down here, I'm sorry, an x minus 2 up here and an x minus 2 down here, and you canceled those out. We will talk about that. That's what we call a hole, and that's in a different video, but you do need to know about those now, because if you cancel those out, you do not have an asymptote there. So, and we'll go over that in another video, but I do want you to know that the very first thing you should do is factor. So if you have a vertical asymptote, again, we set the denominator equal to 0, and if we do that, we get x equals 2, x equals negative 2. Now our horizontal asymptote, we compare exponents. Going back and looking at this original one here, or even this, just knowing that you would have two x's here, so x squared, you'll see that these are the same. And I'm sorry, I just realized that's little, writing over whiteout doesn't show up very well. So x squared over x squared. Remember, if eats DC. This guy right here, remember, is exponents are the same, divide your coefficients. And remember, the coefficients are just the numbers that are right in front of your variables. So we look at this, we see these are the same. So we look at the coefficients, and in this case, they're both 1. So our horizontal asymptote is 1 over 1, which just simplifies down to y equals 1. And just like your vertical asymptotes, you need to write these as the equation of a line. So let's take a look at what that looks like. And I've got that guy plugged in right here, x squared. And sure enough, you can see, we'll zoom in a little, you can see right here at 1, we've got that horizontal asymptote going by. And again, those vertical asymptotes are at 2 and -2, right down here, those vertical asymptotes. All right, so let's take a look at the next one. We have this guy right here. Y equals x squared minus 7x minus 60 over x plus 3. All right, so the first thing we want to do is factor this guy. And if we do that, we end up with x plus 5, x minus 12 over x plus 3. Okay, so there's nothing that we can cancel out here, but it will help us when we go to find our vertical and horizontal asymptotes. So for our vertical asymptotes, I always start with those because those are the easiest ones. That's where we set our denominator equal to 0. And if we do that, we get x equals -3. For our horizontal asymptotes, we see that we have 2 x's upstairs, 1 downstairs. So we have x squared upstairs, x down. If you end up crossing something out, you don't want to go look back at your original. So that's why I'm looking at both of them. But you'll see that the exponent is larger on top. So bigger on top. Let's go back. Bobo button. Bigger on top. This guy right here means none, but check for a slant or oblique asymptote. So for a horizontal asymptote, none, but check for slant. Now, this one happens to have a slant, but we'll talk about that in another video. So check for slant. So this one, like I said, happens to have one, but we'll talk about how to find those in a different video. In the meantime, though, this guy looks like this. So if we come back over here, you can see a slant asymptote is just a line that goes like this. So like I said, talk about that in a different video, but I just didn't want you to be thrown off by the fact that there is a slant asymptote here. Our vertical asymptote is at -3, and you'll see, let's get zoomed right in there. And you can see, sure enough, -3 right here between this -2, -4, you'll see that if I zoom back out, you can kind of see that it goes real close to that, but it doesn't actually cross it. Okay, so let's try our next one. One more example for you. We want to find the vertical and horizontal asymptotes of this guy right here. So again, we want to make sure that we can factor that first. So if we factor that, we end up with, let's see, x plus 2, x plus 1 over 2, x plus 2, x minus 3. So if we factor out a 2 from all of those. Now, here is a good case. You will see that we have ones that we can cross out here. So if we cross these guys out, our new function is f of x equals x plus 1 over 2 times x minus 3. So it's important that we do that because now our vertical asymptote is just x equals, and we would set this equal to 0. We would get, let me do a little side work here so I can show you this. If we set this whole thing equal to 0, we get 2 does not equal 0, so the 2 doesn't matter. And then we get x minus 3 equals 0, and just like we've been doing, x equals +3. So our vertical asymptote is x equals 3. Now, looking at this, we have 1 x upstairs, 1 downstairs, so this would just be x to the 1 power, x to the 1 power. And remember, if they are equal, eats DC. Remember, equal means that we're going to divide our coefficients. So taking a look here, our coefficients, remember, if it's not shown, there's a 1, right? So just so that we can see this a little better, I'm going to say f of x equals 1x plus 1 over, and if I distribute that, I get 2x minus 6. So if I do that, you'll see those coefficients are 1 and 2. So for my horizontal asymptote, it's going to be y equals, divide those coefficients, I get 1/2. So let's take a look at what that guy looks like. So if we look over here, we have this equation right here, and so, or this function, I should say, right here. And sure enough, our horizontal asymptote, if we zoom in there, you can see comes right between 0 and 1 at 1/2. And our vertical asymptote is right there at 3, because remember, x equals 3 for our vertical asymptote, because that will give us a 0 in the denominator. So hopefully this makes a little bit more sense. If you have any questions, let your teacher know. Otherwise, we'll see you next time.